Hi everyone, here are your notes for section 4.3. So as we start section 4.3 and the rest of chapter 4, we're going to be talking about congruent figures, specifically triangles. In the beginning of chapter 4, we talked about triangles, different ways to classify them. The sum of the interior angles add up to 180 degrees, your exterior angle theorem. And then in section 4.2, we got into congruent figures and what does it mean for something to be congruent. And remember, congruent figures need to have all the same sides and all the same angles for them to be the same shape. And then when you do have congruent figures, we know that the corresponding parts will be congruent, which means they're equal in measure or equal in length, depending on if it's angles or sides. So now we're going to look at specifically triangles and different shortcuts that can be used to prove that triangles are congruent. So our first theorem that we're going to be talking about in section 4.3 is SSS, which stands for side, side, sides. Please write the following. If three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. So in our diagram here, again, pause me as you need it. In our diagram here, if the top side of the left is congruent to the top side of the right, and the left of the left is congruent to the left of the right, and then the third is congruent to the third, then I know and have enough information that these triangles are congruent. So if I name this, let's say triangle ABC, and this DEF, I would say that triangle ABC is congruent to triangle DEF, right there's my triangle congruence statement, by the side, side, side theorem. And we can just write it out as SSS. Okay, so 4.3 is pretty easy because all we're doing is looking to make sure all my sides match in length, and if they do, then my triangles are congruent based off of side, side, side. So for our first example, notice on CD you have a single tick mark, and over here you have a single tick mark. So you have one set of sides. I'm going to put a little S here, side congruent to side. And then I have a double tick mark over here, which matches up with that double tick mark over there. So I have a second set of congruent sides. And here I have a side down here with triple, matching with that triple. So all my sides have congruent pairs. So I would say, yes, they are congruent. Triangle, I'm going to name it ABC, is congruent to triangle. Now A, notice, is between the 2 and the 3. What's between the 2 and the 3 on the other side would be E. B, angle B, is in between the 1 and the 3. So what's in between the 1 and 3 over there would be D, and then whatever is left over, which is F. And then we would say by side, side, side. Okay, as simple as that. Do all three sides match up and show congruency? So for B, example B, I have a single tick mark here, single tick mark there. So there's one set of congruent sides. And you can even go as far as putting subscripts if you want it, like side 1, side 1. I have a double tick mark, so S2, S2, so there's my second set of congruent sides. And then here in the middle, we have what we call the reflexive property. The side straight down the middle is congruent to itself because it's the same side, right? If I were to fold that on top of each other, it would be the same length. So we would say yes, and I'm going to say triangle. I'm going to name the top one ACD is congruent to triangle. So now I got to pick out what A would be equal to. So A in this triangle is between the one single tick mark and the triple. So this one tick mark and the triple over on the other side is D. C clearly matches up with B. And then what's left over? A. By side, side, side. Okay. All right, so then we go to C. Do you have three sets of sides? Well, I have a single tick mark. So AC is the same as EF. AB is the same as DE, but I don't have anything here, so I don't have enough information. So I would say not enough info, okay, to be able to do side, side, side. All right, it may be something else. hold out for the future. All right, so I'm going to skip through. So let's just do practice. These are not in your notes. So here, yes, you would have side, side, side. 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 And then we'll pass through all these. Okay, so next example here is on the coordinate grid. So we want to make sure that we've got congruent lengths. So just counting units, 1, 2, 3, 4, 5. Let's see if we got 5 over here. 1, 2, 3, 4, 5. Yep. Then my other side, 1, 2, 3. See if that matches over here. 1, 2, 3. So now all we have to do is find the length of this third side right here. So how do we find the length of a side? Well, we can use the distance formula, or we could use the Pythagorean theorem if you guys remembered that. But if we use the distance formula, remember the distance formula is equal to x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So that's equal to the square root of, let's call this x1, y1, and negative 7, 0 can be x2, y2. So we have my x sub 2, which is negative 7, minus a negative 4, so plus 4 squared, plus my y sub 2, which is 0, minus 5 squared. Negative 7 plus 4 is negative 3, then I'll square that, and negative 5, I'll square that. So I get 9 plus 25, which is the square root of 34. Can't simplify that. Let's do it to the other one. x1, y1, x2, y2. So my distance over here is going to be my second x, which is 1 minus 6 squared plus my y, 2 minus 5 squared, gets me negative 5 squared plus negative 3 squared, which looks very familiar to the last one. So 25 plus 9, so 34. So are they all congruent? Yes. All sides are congruent. We showed it by marking all the congruent lengths. Okay. All right, next one. We're going to go ahead and skip this one, so just put a big X through it. Oops. And then for the last one, we're going to state the additional piece of information needed to show that each pair of triangles is congruent by side, side, side. So we've got one set of side 1, side 1, side 2, side 2. So what's missing is side 3 with side 3. So what would that look like? We would need AB to be congruent to A would match up with I, B would match up with H. That would be the last piece of information we would need. Okay, that concludes your